To the graphing, I have to make sure you guys can find all the important pieces. So again, we said none of these have holes, which means none of them have factors that cancel out of the numerator and denominator. That means that we want to look for all the asymptotes and the x-intercepts. Okay, so types of asymptotes. There's vertical asymptotes, and you guys can totally abbreviate anything the way that I do. So 3 kinds of asymptotes. There can be vertical asymptotes, horizontal, or oblique asymptotes. Okay? The horizontal and oblique asymptotes, if you have one, you don't have the other. Because remember, those 2 things are where the ends of the function follow. So they either follow a horizontal line or they follow some slanted line. They can't do both. Okay? So if you have one of these, you don't have the other one. Okay? And then we want to list our x-intercepts. All right, so before we do that, we'd want to look at our function and see if we can factor the numerator or the denominator. So does anything in this equation factor? No. Okay? So that part's done for us. So then, either from memory or based on what your sheet says, how do we determine where a vertical asymptote is? James? Good. Wherever the denominator is equal to 0, there is an asymptote there. So our denominator says x minus 6. You set x minus 6 equal to 0, you would get that x is equal to 6. That means there is a vertical line cutting through your graph as an asymptote at x equals 6. So the equation of the vertical asymptote is x equals 6. And yes, you need the x equals. Vertical lines and horizontal lines, they have different equations. Okay? Horizontal and oblique asymptotes, again, remember, are exclusionary. If you have one, you don't have the other, and both of their equations start with y equals. Either like a y equals mx plus b type of thing for an oblique one, or y equals a number for a horizontal one. Okay? All right, so who can help me with how we make the decision about horizontal asymptotes? We did this whole investigation on Friday with the crazy chart to try and figure out, like, if things went to infinity or to 0 or to some other number. And then we looked at the functions and tried to figure out why that happened, and we found like these 3 different categories of how things worked. So what did we look at to determine this? Good. Okay, the exponent in the numerator and the exponent in the denominator, and we call that degree. So what is the degree of the numerator? 1 is the highest exponent on x. And in the denominator? 1. They have the same degree. So what did we say when functions have the same degree? Is there no horizontal asymptote? Do they level out to 0, or do they level out to some specific number? Some specific number, and how do we find that number? Yeah, basically pretend like all the other stuff doesn't exist and just take the first pieces and divide them. So basically if you had 3x over x, that would reduce to be 3. So our horizontal asymptote is at y equals 3. And if we have a horizontal asymptote, what does that mean about oblique asymptote? We don't have one because there's one or the other. So we can just write none. Okay? How did we decide we would find x-intercepts? So again, you can look back at the notes that you took for reference. So vertical asymptote was when the denominator was equal to 0. How do we find x-intercepts? Then when the numerator equals 0. So I would think about 3x plus 5, set that equal to 0. You guys can solve that equation, and when you do, you get negative 5/3. Now, an x-intercept isn't a line, it's a point, so we will write it as a point. It is the point negative 5/3, comma 0. Always 0, because you set them equal to 0, and they're on the x-axis, so they can't have a y-coordinate. Okay? So is this okay review about how we find the asymptotes and the intercepts? So the only thing that wasn't up here was holes, and we'll talk about that tomorrow, how to insert a hole. Okay? Today we just want to talk about how to get this stuff and then get this stuff on the graph. All right, for part B, we're going to do the same thing. And again, before we start and set things equal to 0, we want everything in the most factored form that we can get it in. So is there any part of our equation in part B that needs to be factored? Can the denominator be factored? No. Can the numerator be factored? Yeah. Okay, the way that I would look at it is I would take out a negative first. Okay, and then when you see it as x squared minus 1, how does x squared minus 1 factor? Yeah, x plus 1 and x minus 1. And again, the reason we do this is a couple of things. One, if anything canceled, we want to cancel it at this point. And two, when I set the numerator equal to 0, if I already have it set up in factors, I can see like all the different values of x that would give me 0. Okay? All right, so asymptotes could have vertical, horizontal, or oblique. And then we want to find our x intercepts. Okay? All right, so vertical asymptote. Who can tell me what it is and why? Hannah? Good. X equals -5. Someone else tell me how she got that. Good. She set the denominator equal to 0. So x equals -5 will be this vertical line running through my graph. Okay? All right. Horizontal asymptote. Is it 0? Is it a specific number? Or is it none? Okay, so I hear a vote for none. Can anybody tell me how that decision was made? Yeah, Stephen? Okay, but the degrees aren't equal, but it's good that you're looking at the degrees. What is the degree of the numerator? 2. And what is the degree of the denominator? 1. Which means when you start plugging in really big numbers, the numerator is just growing off the charts faster than the denominator, so it's just like going to shoot up or shoot down if it's negative. Okay? So this was the case where we had no horizontal asymptote, which means we do have an oblique asymptote, and we'll talk about how to get that equation in a minute. What about x intercepts? When would the numerator equal 0? James? Do you guys see why he's picking out two values? Okay. If you set the factored form of this equal to 0, you can set each factor equal to 0 so you can get x equals -1 and x equals +1. So it has two x intercepts. So again, those are points. So it's at 1, 0 and at -1, 0. All right. So, yes.
I have a question.
Uh-huh.
Like, if you still have the negative there, and let's say inside it was like x plus 5 and like x minus 3, would you have to flip the signs for whatever it is?
No, you can still set each factor equal to 0. And the thing would be with the negative here is like having a -1, and -1 cannot equal 0 because it doesn't have an x. So you're fine. You don't have to worry about it once you've factored it out. Just any factor containing x, set that equal to 0 without changing it, and you're fine. Okay? All right, so for oblique asymptotes, that means when our function at the very ends of it doesn't go straight, so it doesn't start settling down to one thing. Instead, there's some sort of slanted line on our graph, and our function starts to follow that slanted line. Okay? That means it has a slope, meaning its equation will look something like a y equals mx plus b kind of idea. Okay? Yes? So the degree in the numerator is 2. Whenever the degree of the numerator is higher, it doesn't have a horizontal asymptote. Okay? All right, so how to get the equation? You're going to get the equation by literally dividing the problem. So a fraction bar literally means division, right? We're actually going to divide it out. So you might have to write a little more than some other people in this case, depending on how well you remember division from Algebra 2. So we literally want to take -x squared plus 1 and divide it by x plus 5. Okay? So we're going to do a division problem. X plus 5 is going into -x squared plus 1. Now, before I write down -x squared plus 1, the best thing to do for you to make sure that everything lines up properly is take the highest degree term, and you need to have something for every degree below that. So this term has degree 2. Does our function have a term with degree 1? Something that just has x to the first power in it, in the numerator? No. So basically, I'm going to put a little placeholder in there. It's nothing, but it'll just make sure all your numbers line up right when you're doing the division problem. Okay? And then all the way down to a constant. So I have x squared. I put in an x because there wasn't one there, but I made sure it had a 0 in front of it, so I didn't change it. And then plus 1. So if you remember from Algebra 2, not. We're walking through the whole thing right now, so just take the extra notes you have to take. When you do this division, basically you look at the first thing here and you ask yourself, what do I have to multiply that by to make it look exactly the same as the first term here? Okay, so what times x would make negative x squared? Negative x. So that's my choice. Okay. I put it 2 spaces over because once I multiply it through, there's actually 2 things here that it has to multiply by, so it'll take up 2 spaces. Okay. And then you take what you chose, and just like with division with numbers, whatever you chose multiplies what's over here. You write it down here, and then you subtract it. Okay? So negative x needs to multiply x plus 5. That means distributive property. So negative x times x, negative x squared. Negative x times 5 is negative 5x. This is why I had to put that 0x there. Otherwise, you guys would have this lining up with the 1, and you might accidentally add them together, even though they're not like terms. Okay? Now, in division, once you've multiplied this times this and written the answer here, what do you do with the 2 things that are right here? You subtract them. So remember, subtraction with numbers is a little easier. When you have multiple terms, that means if you're subtracting all of this, that the sign's being distributed. Right? So the easiest thing to do is to go through and just like change all of the signs. Okay? This first term then should cancel out. If it doesn't cancel out once you subtracted it, you didn't choose the right thing. Okay? That's how you're doing the division process, is you're kind of eliminating it term by term. And so now we have 0x plus 5x, which would give us 5x, and then you drop down the next term. So just like long division with numbers, but you have like these variable pieces to it. And then you start over and you ask yourself the same question again. What would I want to multiply times x so it looks exactly like 5x? So what would the answer be? 5. So positive 5. And then you actually take that positive 5 and multiply it through x plus 5. So 5 times x is 5x. And 5 times 5 is 25. But again, you're not adding them together, you're subtracting. So again, the easiest thing to do is to change all the signs of the terms that you just wrote across there. The first term should cancel, and then we have 1 minus 25, which is negative 24. So technically, you're done with the division problem, and the answer is negative x plus 5, and then it would have this remainder attached to it. But I'll say this once, and then you guys will just kind of catch on to do this every time. Remember, the only purpose of the oblique asymptote is to tell you what's going to happen way at the end of your graph, right? Not in the beginning, but just at the end, what line will your graph follow? What would happen to this little fraction right here if I put in some really, really big numbers for x? It's going to get really small. Like if I put 1,000,000 in for x, what's 24 divided by 1,000,005? Something really small, right? Then what if I put in like 1 billion? 24 divided by 1,000,005 is like something even smaller. So basically, the remainder ends up not mattering, okay? Kind of goes off and becomes 0. And this is what you're going to use as the equation of your oblique asymptote. So the remainder matters in division, but does it matter to us when we're trying to find how the function is going to behave at the end? No, only the main terms of the problem do. So our final equation for our oblique asymptote is exactly what we got after we divided. Okay? So why don't you guys go back to the sheet about horizontal asymptotes, vertical asymptotes, all of that, and it says, how do you find an oblique asymptote? Write down that you need to divide the polynomial, okay? Or use division. Some note like that so you figure out how to do them, okay? That sheet, I think you were here. That one was the first day. I didn't give out any of these. It looks like this. And we put the parent function on. All right, so same thing. First of all, can we factor anything? Yes, numerator or denominator or both? Denominator, okay. So what can you factor in the denominator? So they have a greatest common factor of 2x squared. So the numerator will stay how it is. And in the denominator, I will factor out a 2x squared. And I will get x plus 2. Right? And now that it's factored, I can try to answer all those questions I have to answer. Okay? All right, so new people each time. Who can tell me vertical asymptote? And I'll start picking on people that haven't talked. So if you know, you should say now, so then you won't get stuck saying. So what's the vertical asymptote of this function? Davis. Okay, good. That's one of them. There's actually another vertical asymptote in this function as well. So x equals -2 is one vertical asymptote, James, and x equals 0. Why do I have two vertical asymptotes in this case? Yeah, if you set this factor equal to 0, you get that x would equal 0. If you set this factor equal to 0, you get x equals -2. That means there's two different x values that would make the denominator equal to 0, so both of them show up as vertical asymptotes. Okay. All right. Horizontal asymptote, and if it's none, we'll move on to oblique asymptote. Who can tell me about our horizontal asymptote? Alexis? Good, it is y equals 0. Who can tell me how she determined that? So what do we look at for horizontal asymptote? What have we been focusing on? The degree, okay? Who wins in this case, numerator or denominator? Denominator. And when that's the case, the horizontal asymptote always ends up at 0. So if the denominator has the higher degree, it's at 0. If the numerator has a higher degree, there's not one, and there's a lot of work to go find the oblique asymptote. If they're the same, you just take the coefficients and you get some number for the horizontal asymptote. So because there is a horizontal asymptote, I get to write none for my vertical asymptote, or my oblique asymptote. Okay. And then what about our X intercepts? So how do I find them? Okay, so Stephen says that the numerator equal to 0. So even though it's not factored, and it has an x squared, that's okay. So it couldn't factor. It just makes our life maybe a little harder while solving. Then we're going to solve for x here. Okay? So first you're going to get x squared alone. You're going to subtract 1 and then divide by -2. So you're going to end up with 1/2 on the other side. Okay? How do I finish solving for x in this equation? What do I do? I have x squared equals 1/2. What do I do to get x alone, so to speak? Square root. And what are some key things to remember when you solve an equation by square rooting both sides? There's two answers. So it's not just that x equals the square root of 1/2. It's that x equals both the positive and the negative square root of 1/2. The square root of 1/2 will be 1 over the square root of 2. But you know how we are with math, just like English, there are some grammar rules where you're not supposed to leave a radical in the denominator. So if you multiply top and bottom by the square root of 2, you get root 2 over 2. Okay? So our x-intercepts are two of them. Okay? Positive root 2 over 2 and 0, and then negative root 2 over 2. Okay? So we took the square root, we got plus or minus. There's the square root, and then multiplying top and bottom by the square root of 2 would give us no more radical in the denominator. Okay. Are we okay with pulling out the information now? Feel okay with that? All right, so once you pull out the information, the whole purpose is to use that information to get a quick sketch of what this graph looks like. So in example 2, if you have the note-taking guide, if not, I'm going to put it up and it's going to say example 2 part A, but it's really just going to graph this stuff. So if I were you, I would just do the graph right next to where you have all of the work. Okay? I'm going to transfer my work to make less work for myself. Okay. So here's all the work that you just did for that equation. So what does this mean on the graph? Okay. So asymptotes. Asymptotes are going to show up on your graph as dashed lines. Okay. So vertical ones will be vertical dashed lines. Horizontal ones will be horizontal. Oblique would be some line with a slope. X-intercepts are points, and they're on the x-axis. So we want to put all of these things onto our graph. Small note, so that you guys don't have to calculate it. I'll either give you nicer numbers on the test, or I would give you some way to figure it out. I wouldn't expect you just to know, but root 2 over 2 is approximately 0.7, okay? So just when we're putting those on the graph, we know where to put them. So if I go to put these things on the graph, first of all, I'm going to put in these 2 vertical asymptotes. So I'm going to make dashed vertical lines at x equals -2 and at x equals 0. So you guys can go ahead and put those on the graph. So remember that vertical asymptotes, your function follows them when they go up or down, but they also are like complete dividers of your graph. They cannot be crossed. Because these were x values that if you plugged them in, made the function undefined. They are like unusable x values in this equation. Okay? The horizontal asymptote is at y equals 0. So there will be a horizontal line at y equals 0. Again, I will draw it dashed. But this asymptote is a little bit different. Things can cross this asymptote, but what is the purpose of a horizontal or oblique asymptote on my graph? Why is it there? What did we say it tells us about the graph? Which direction it will go at the ends, right? So it tells you just about the behavior of the graph at the very end. So all this crazy stuff could kind of happen at here, but once I get way out there, I expect it to even out and be like this. Does that make sense to everybody? Okay. So know what those things are. I will ask you on your test, like, what is a vertical asymptote for? What is a horizontal asymptote for? Okay, so horizontal and oblique asymptote tell you about the behavior at the end of the graph. Vertical asymptotes, you cannot cross because your graph is undefined at those values. Okay, they're like separators of the graph. Okay, and then our intercepts are point on the x-axis. So put a point at 0.70 and negative 0.70. So like, I know, we can't tell exactly where the 0.7s are or whatever. Now here's how we're going to graph it. These graphs can be crazy shapes, okay? There can be a lot of stuff happening in between. So basically, all we're going to do is decide if the graph is above the x-axis or below the x-axis, and then we're just going to use our asymptote to try and sketch the curve. So what I mean by that is in this first section here, I either expect my graph to kind of be a curve like this, or I expect it to be a curve like this. Okay, don't write either of those down because I'm not done. I'm just showing you my expectation. Why do I expect that? Are there any x-intercepts here? No. So I don't think it crosses the x-axis here. And I know that it has to eventually follow this horizontal line and eventually follow the vertical line. So how am I going to decide if it's up here or down here? I'm going to plug something in and see if it's positive or negative. If it's positive, it has to be up here. If it's negative, it has to be down here. Okay? So basically, we're going to come up with this method where we just create a system where we plug in a bunch of stuff. And when we plug in that stuff, it'll tell us where to draw our curve on the graph. Okay? So the numbers that we plug in are x's. And we want to separate them by the way the x-axis is separated. So a horizontal asymptote or oblique asymptote doesn't affect our x-axis. Okay? It's y. Okay? But all of these things do. So asymptotes and intercepts are important things on our x-axis. So we're going to draw kind of a little replica of our x-axis here just to figure out what's happening in the graph. Okay? So we're going to think of this like our x-axis with all the important separators that are on it. So there's an asymptote here at -2. So there's something happening at my graph at -2. Okay? There's an intercept here at -0.7. So there's some sort of intercept at -0.7. There's another asymptote at, and then there's another intercept at +0.7. Basically, all those things break my x-axis up into sections. What happens when you plug in numbers smaller than -2? What happens when you plug in numbers between -2 and -0.7? Between -0.7 and 0, between 0 and 0.7, and bigger than 0.7. Okay? So the more sections you have, kind of the more work that you have to do. Okay? We only care if they're positive or negative. We don't care about actually plotting a point. So basically what you want to do is you want to figure out if the fraction is positive or negative. Okay? So right now you have a fraction. So I'm just going to make a fraction bar. So everybody think in your head a number that's smaller than -2. Okay? When you plug your number that's smaller than -2 into the numerator, so like say your number is -3, that's my number, okay? I would square it, that would give me 9, times it by -2, that would be -18, plus 1 would be a negative number. So when I plug my number into the numerator, I get a negative value, okay? You should have 2, even if you picked a number different than negative 3. That's the beauty. They keep working out the same, okay? Now let's say I plug my negative 3 into the denominator, okay? Negative 3 cubed is like negative 27 times 2 is like negative 50-something. I don't have to be exact because I just have to work out if it's negative or positive. So it's like negative 50-something, and then here, negative 3 squared is 9. 9 times 4 is 36. I have more negatives than positives when I plug that in and add it up, so it'll be negative also in the denominator. What is a negative divided by a negative? Positive. So overall, I don't know what the number is, but I know it's going to work out to be a positive in this area of the graph. Okay? That means, here's my asymptote at negative 2. I expect the graph to have all positive y values. So should I draw the curve below my horizontal asymptote or above? Above. So I would just draw it following the asymptotes. Is it exact? No. It's a sketch. I just have to put the curve in the right spot. Okay? So I'm not looking for exact accurate points here. I'm just looking for draw the curve in the right spot. Okay? Then I have to know what's happening from the asymptote to negative 0.7 right here. Is it up here, or is it down here and coming up to that point? So to make that decision, that's why I want to plug a number in that's between negative 2 and negative 0.7. Let's say negative 1, because that'd probably be the easiest number to plug in between those. When you plug in negative 1 to the numerator, do you get negative or positive value? Negative. When you plug in negative 1 to the denominator, in the denominator, 2x cubed plus 4x squared, plug negative 1 in for x. Do you get negative or positive answer? Positive. So you get a negative in the numerator but a positive in the denominator. What's a negative divided by a positive? Negative. So basically, everything is supposed to be below the x-axis between negative 2 and negative 0.7. So if you're supposed to follow this asymptote, you either had to be way down here following it or way up here. If you know you're supposed to be negative, were you way up here or were you way down here? You must have been down here. And so somehow the curve followed the asymptote and then made it to that point. At that point, it either turned around and went back down and followed this asymptote, or it's going to go through that point and it's going to follow this asymptote upward. Okay? How do I decide? Well, I need to find a number between negative 0.7 and 0 and plug it in. Okay? So you can plug in negative like 1/2. Okay? I'll help you guys do the arithmetic for this one. I would either give you a calculator in this case. Okay, I don't care that much about if you can do the arithmetic in your head. So if you plug in negative 1/2, okay, if you square it, you get 1/4 times negative 2. Negative 1/2 plus 1 is a positive. Okay. And in the denominator, you get negative 1/8 times 2 is negative 1/4. But there you would have something, let's see, 4 times 4 is 1. So it would also be positive, which means positive divided by a positive is positive. I don't care if you guys followed me with the 1/2. I would let you use a calculator. But do you guys understand what I'm doing when I'm plugging in a number? I'm just plugging it into the top of the fraction and seeing if it's negative or positive. Then I'm plugging it into the bottom and seeing if it's negative or positive. And then I'm just saying, how does that work out? As a negative or as a positive? Alexis? And then past it, yeah. And basically for every X intercept and vertical asymptote. So the less of these that you have, the less plugging in you'll have to do. Okay? All right, so this ended up being positive, which means it must cross through this point and go up positive and follow this asymptote up there. Okay? Then the question is, the asymptote creates a break in my graph. Either the next piece of the graph was down here following the asymptote or up here following the asymptote until it gets to that point. Okay? So again, to make that decision, I need to plug in a number that's between that asymptote and that point. So between 0 and 0.7. So this time I could plug in like positive 0.5. Okay, or 1/2. So you would get a positive in the numerator, so that stays. And there's nothing, if I'm plugging a positive number in the denominator, it's going to all stay positive. So it would also be positive. Positive divided by positive is positive again. So this one must have been up here, followed the graph down to this point. Sorry that it's a little bit wavy. And then the question is, what happened after that? Did it turn around at this point and stay up here? Or did it go below this and then eventually just come follow the asymptote later on? So then I need to take a number past 0.7 and plug it in. So I would choose 1, okay? And like as simple as I can get. So when I plug 1 into the numerator, would it be negative or positive? When you plug 1 into just the numerator of that fraction, would it be negative or positive? Negative, okay? So this would be negative. And when I plug 1 into the denominator, positive. A negative divided by a positive is negative. So that means it must go through this point. So I'd picture something like this happens. But here's the deal. I know it's supposed to even out to look like this. I have no idea how far it goes, when it turns around. I don't care if you guys know that. I just want to sketch. I don't want a perfect graph. But if you know it's supposed to come back and follow this, come back and follow this. So even though I know it goes below, it must eventually come back and follow that straight line. Okay? Right? So getting all that stuff on your graph is most important because then it gives you what you're going to plug in to do other things. Okay? All right, so I'm going to have you guys try to graph one on your own. Okay? So what you're going to do is you're going to find all this stuff. You're going to put it on there. And then you're going to try and find the graph. Let's see. I don't want you to do... Okay, we're not going to do part B for right now. We're going to go to part C because part B has an oblique asymptote, and we'll do that one later. Yeah, that's fine, dude. All right, so go ahead and do this one. And I'm going to factor the denominator for you to save you some time. So then remember, you're going to list the vertical asymptote, horizontal asymptote, oblique asymptote, X intercepts, and then you're going to try and graph it, okay?